Hello students, how are you all? I hope you are doing well. Now we are going to discuss chapter 13, Time and Motion. Let's warm up. In your daily routine, there are many things which require you to rely on time. Mention such 5 things here. So students, you have to do it by yourself. Let's know about time, types of motion, speed, distance, time graph. So students, these are some topics we are going to discuss in this chapter. The first we have time. Time is the duration which things occur. The knowledge of time is essential for carrying on our daily life activities. For example, our school starts at a particular time. We use our wristwatch to know the time so that we may reach the school on time. Similarly, we need to know the time to catch a bus, a train or an aeroplane for making a journey. We also have to know the time to listen to a particular radio program or to watch a favorite television program. We measure time with the help of clocks and watches. So student, आप सबको पता है कि टाइम आप सबके लिए कितना important है और टाइम हम किसकी हेल्प से मेजर करते हैं? Clocks and watches. Now we have measurement of time in ancient times. Long ago, people did not have clocks or watches for measuring time, but people realized the importance of time. Our ancestors used some natural events which repeated regularly after definite intervals of time to measure the time. So students, हमारे ancestors क्या use करते थे? कुछ natural events जो definite interval of time के बाद क्या होती थी? Repeat होती थी. For example, look here students, the time taken between one sunrise to the next sunrise was called time taken between one new moon to the next new moon was called month. So students, these are the types that our ancestor watch, our ancestor define times. Here we have some clocks, sun clock, sundial, water clock. The time taken by the earth to complete one revolution of the sun was called a year. Some of the important time measuring devices used in ancient times were sundial, sun clock and water clock. Look at this picture students, we have Jaipur's Jantar Mantar. The first we have sundial. Sundial is one of the earliest devices used to measure time. A sundial measures time by the position of the shadow cast by the sun. The sundial has a triangular blade which is fixed vertical on a dial marked with hours of the day. The sun casts a shadow of this vertical blade on the dial. As the position of sun changes in the sky, the position of the shadow of the blade on the dial also changes. The position of the shadow of the vertical blade on the dial gives the time of the day. So student, that's how sundial works. Sundial ऐसे work करता है कि जो आपकी shadow जो cast होती है उसके according वो time को measure करते हैं. Now we have water clock. Water clock was yet another time measuring device used in ancient times. A water clock uses the rate at which water drips from one vessel to another to measure time intervals. Water was allowed to drip from one vessel to another vessel kept at a lower level. Time taken by the entire water to dip from the upper vessel to the lower vessel was used for measuring time intervals. Every time the upper vessel is filled with water, its water takes exactly the same time to drip into the lower vessel. So students, क्या होता था कि दो vessel connect होती है, जैसे आपने अभी देखा, तो first vessel से जितना time second vessel को fill होने में लगता है उतना ही second से first को fill होने में लगता है. So that's how वो time को उससे measure करते थे. Now we have sun clock. Another early device for measuring time was the sun clock. Sun clock is also known as sun glass or hourglass. The sun clock uses the flow of sun to measure time. The length of time taken by the sun to pass from one bulb of the sun clock to other gives a constant time interval. A sun clock consists of two glass bulbs joined together through a narrow tube. Some sand is filled in one of the glass bulbs. The two glass bulbs are closed at the other end. So students, it's also similar to the water clock. Now we have candle clock. It uses a candle with nails inserted into it are fixed gaps. The candle is capped on a metal plate. When the candle burns to the point where the nail is fixed, the nails falls on the metal plate, producing a sound. This happens at irregular intervals. All these instruments were not able to give accurate time. The need for accurate time measurement therefore led to the invention of mechanical clocks. Mechanical clocks were built in tall towers as the weights needed space to fall or move downwards. These clocks worked for a short period of time, only maximum for 2 hours. In 1656, Christian Huygens, a Dutch mathematician and physicist, invented the first pendulum clock which measured time using the periodic motion. So students, पहली जो वॉच डेवलप की गई थी वो एक डच मैथमेटिशियन और फिजिसिस्ट थे जिन्होंने की थी और वो बेस्ड थी पीरियोडिक मोशन पे. नाउ वी हैव पीरियोडिक मोशन. Any motion that repeats itself at fixed intervals is called a periodic motion. Some examples of periodic motion are rotation of Earth on its axis and revolution of Earth on its orbit. The motion of simple pendulum is also an example of periodic motion. So student, periodic motion क्या होता है? जब कोई motion जो है after a regular interval of time repeat हो. Now, do you know? Galileo was the first to experiment with pendulums and find out their unique characteristic that could be used to measure time. Now we have simple pendulum. Let's learn some more about a simple pendulum. It contains a small mass called bob, suspended from a fixed point through a long string or rod. The mass moves freely under gravity. The motion of a pendulum is called oscillatory motion. When the bob of the pendulum moves from one point, goes on the opposite side and comes back to its original position, it is said to complete an oscillation. The time taken by the pendulum to complete one oscillation is called its time period. It is interesting to know that for small displacements, the time period of a simple pendulum remains constant. The time period is independent of the mass of the bob. The time period of a pendulum depends upon the length of the string from which the bob is suspended. Longer the string, greater is the time period. Earlier clocks were based on the oscillation and constant time period of a simple pendulum. So student, I think everyone know about the simple pendulum. आप सबने simple pendulum देखा होगा. Look at this picture. We have simple pendulum, Galileo simple pendulum. So एक जो आपका जो simple pendulum है वो जो एक revolution एक round complete करता है, that is oscillation. और simple pendulum कौन सा motion से वो करता है, that is oscillatory motion. Now we define certain terms related to study of simple pendulum. The first we have length of the pendulum. The length of the string thread from the point of suspension to the center of the bob is called the length of the pendulum. Then we have mean position of the bob. The position of the bob when it is at rest is called its mean position. Then we have extreme position of the bob. The position where the bob is the maximum distance from the mean position are called extreme positions. Now we have oscillation of the pendulum. The motion of the bob of a pendulum from one extreme position to the other extreme position and back is called an oscillation of the pendulum. For example, in the motion of the bob from its extreme position to another extreme position and back to the previous extreme position is called an oscillation. So students, get it what is an oscillation? Now we have amplitude of pendulum. As the pendulum oscillates to and fro, the maximum displacement of the bob from its mean position on either side is called the amplitude of pendulum. Now we have time period of the pendulum. The time taken by the bob of a pendulum to complete one oscillation is called the time period of the pendulum. Now students, we have an activity, activity 1. Aim to determine the time period of a pendulum. Materials required a metal ball, bob, a string of length 1 meter, an iron stand, a stopwatch. Method: set up a simple pendulum as shown in with a string or thread of length 1 meter carrying the bob at lower end and tied to its upper end from a rigid support like iron stand. Second, switch off the nearby fans. Third, let the bob of the pendulum come to rest at its mean position. Mark the position of the bob on the floor below it. Fourth, to set the pendulum in motion, hold the bob gently and move it slightly to one side. Now, release the bob from its displaced position gently. Do not push the bob while releasing it. Ensure that the bob does not spin on its axis while oscillating. Come to the next we have start the stopwatch when the bob is at one of the extreme positions. Keep on counting the number of oscillations made by the pendulum bob. Next step we have measure the time taken by the pendulum bob to make 20 complete oscillations. Divide the time taken for 20 oscillations by 20. This will give us the time taken by pendulum for making one oscillation. It is the time period of the pendulum. Look at this picture students. Time period of pendulum. That's how you have to make your setup of this activity. Calculation. Time taken for 20 oscillation is equals to 48 seconds. Time taken for 20 oscillation is equals to 48 seconds. Time taken for 1 oscillation is equals to 48 divided by 20 is equals to 2.4 seconds. Time period of this pendulum is 2.4 seconds. So that's how you can calculate the time period of a simple pendulum. Here we have numerical. A simple pendulum takes 32 seconds to complete 20 oscillations. What is the time period of this pendulum? So here is solution. Time taken for 20 oscillation is equals to 32 seconds. So time taken for 1 oscillation is equals to 32 divided by 20 is equals to 1.6 seconds. Thus the time period of this pendulum is 1.6 seconds. Now we have check and mate, as we already read about these things, so you can do it by yourself. Now students, we have latest trend in measurement of time. Quartz is a hard mineral consisting of silica. These days most of us use quartz clocks and watches. These watches measure time accurately. So most of the accurate clocks and watches these days use quartz crystals. Crystals for measuring time. The clocks and watches which use quartz crystals for their working are called quartz clocks and quartz watches. Look at this picture, latest time measuring device watches. Quartz has a unique property of oscillating when subjected to a small amount of electric current. In these watches, an electric cell and a quartz crystal are placed in an electric circuit. So student, आज के टाइम में जो हम यूज करते हैं that is a quartz watch or quartz watches and quartz clocks. For measuring short interval of time, a stopwatch is used. It can be made to start a stop with the help of a push button and is used to measuring time at a sports event. It can measure 1/10 of a second. Here we have unit of time. The standard unit of measuring time is second and is written as small s. The last units of time are minutes and hours, written as min minute and small h. Some units and their conversions are as follows. We have 60 seconds 1 minute, 60 minutes 1 hour, 24 hours 1 day, 30 days 1 month, 12 months 1 year, 10 years 1 decade, 100 years or 10 decades is equals to 1 century. 1000 years or 10 centuries is equals to 1 millennium. So students, these are some conversions. Now we have type of motion. An object is said to be moving if it changes its position with respect to a fixed point or object with time. Also, an object is said to be at rest if it does not change its position with respect to a fixed object or a fixed point with time. Motion and rest are relative terms. Different objects show different types of motion. In our previous classes, we have learnt that there are 4 important types of motion: rectilinear motion, circular motion, rotational motion and periodic motion. The first we have rectilinear motion. Motion in a straight line is called rectilinear motion. The motion of a bicycle moving on a straight road is rectilinear motion or motion along a straight line. Then we have rotational motion. When an object turns or spins about a fixed axis, it is called rotational motion. The earth turns round and round on its axis like a spinning top. So the spinning of the earth on its axis is an example of rotational motion. Then we have circular motion. A round path having the shape of a circle is called circular path. When an object moves along a circular path is called circular motion. For example, the earth moves around the sun in a circular path or circular orbit. So the motion of the earth around the sun is a circular motion. Now we have periodic motion. The motion which repeats itself after regular intervals of time is called periodic motion. Periodic motion is also called oscillatory motion. The swinging of a pendulum is an example of periodic motion. Some other examples of periodic motion are motion of swing, motion of hands of an athlete while running a race, motion of a child on a seesaw. Now we have speed. There are a number of situations in everyday life where we used to understand slow-moving fans is less effective on a summer evening while a fast-moving fan is able to circulate more air in a room. If you have to travel to a distant city as quickly as possible, you will definitely prefer an aeroplane than a train or a car for simple reason that the aeroplane travels faster than a train or a car. Slow-moving air is called a breeze and is pleasant to feel, while fast-moving air causes storms and tornadoes which are disastrous. This example clearly indicates that to know precisely how fast or slow an object is moving, we need to measure the first distance traveled by the body, second time taken to travel the distance. Here, speed is equals to distance traveled by time taken. Suppose a car travels distance of 100 kilometers in 4 hours. The speed of this car is given by speed is equals to 100 kilometers divided by 4 hours. Speed is equals to 25 kilometers per hour. Thus, the speed of this car is 25 kilometers per hour. In other words, the car travels a distance of 25 kilometers every hour. The speed of 25 kilometers per hour can be written as in short form as 25 kilometers per hour. Note that meter per second is the SI unit of speed. The speed of an object is usually not constant and the distance traveled divided by times give us the average speed during that time. When the road is straight, flat and free, the speed may be much more than 25 kilometers per hour, but on bends, hills or in a crowded area, the speed may fall well below this average value. We have just studied that the formula for calculating the speed of moving object is speed is equals to distance traveled by time taken. We can rearrange this formula and get two other relationships for calculating the distance traveled and time taken as follows. The first we have one relation obtained by rearranging the speed formula is distance traveled is equals to speed multiplied by time taken. And the second we have another relation obtained by rearranging the speed formula is time taken is equals to distance traveled by speed. Here, units of speed. The standard unit of distance is meter and that of time is second. So, the standard unit of speed is meter per second. Another unit of speed is meters per minute, which is written in short form as meter per minute. Now, we have speedometer and odometer, an instrument on a vehicle's dashboard which indicate the speed of the vehicle while it's running is called a speedometer. Look at this picture we have. It is a speedometer. The speedometer has a symbol kilometer per hour written on its dial. Most of the vehicles have needle type speedometer, but these days vehicles are also coming with digital speedometers. In a vehicle, there is also an instrument called odometer. Odometer is an instrument of measuring the distance traveled by a vehicle. Odometer records the distance traveled by a vehicle in kilometers. The meter fitted on the top of the handles of the scooters and motorcycles have an built speedometer and odometer. Now we have a numerical. Roma walked a distance of 270 meters from her home to park in 3 minutes. What was her speed during this walk? Distance 270 meter time 3 meter. Time 3 minutes. So, speed is equals to 3 multiply. Now, time we have 3 minutes. So, you can convert the time into seconds. That is 3 multiplied by 60 seconds is equals to 180 seconds. Now, speed is equals to distance traveled by time. Here is equals to 1.5 meter per second. Look here, it is the picture of odometer plus a speedometer. Now we have uniform and non-uniform motion. Suppose an object, say a car or a bike, keeps on moving only one way along a straight line path. If it keeps on covering equal distances in equal interval of time, its speeds remain constant. We call the motion of such an object a uniform motion. Thus, an object moving along a straight line path is said to have a uniform motion if its speed remains constant. But this may not much actually be possible in day-to-day situation due to heavy traffic, bad roads, etc. This is real situation. Thus, in real situation, we hardly find bodies moving at uniform motion. An object moving along a straight line path is said to have non-uniform motion if its speed keeps changing. It does not remain constant. An object having non-uniform motion travels unequal distances in equal intervals of time. An object having non-uniform motion travels unequal distances in equal intervals of time or equal distances in unequal intervals of time. If we calculate the speed of the train for various distances, we will realize that the train has not traveled at the same speed. So, the motion of the train is called non-uniform motion. So, student, यूनिफॉर्म और नॉन यूनिफॉर्म में सिर्फ इतना सा डिफरेंस है कि यूनिफॉर्म मोशन की बात जब हम करते हैं तो कोई भी ऑब्जेक्ट यूनिफॉर्म मोशन में अगर ट्रेवल कर रही है सो दैट मींस वो इक्वल डिस्टेंस इक्वल इंटरवल ऑफ टाइम में ट्रेवल कर रही है. जब हम नॉन यूनिफॉर्म की बात करते हैं या तो डिस्टेंस अनइक्वल होगी या फिर आपका टाइम अनइक्वल, टाइम इंटरवल जो है वो अनइक्वल होगा. सो दैट इज नॉन यूनिफॉर्म. And in our life, in our day-to-day life, we always follow the non-uniform motion. Now we have distance time graph. A graph is a diagrammatic representation depicting an interrelation between two quantities. A graph consists of two perpendicular lines meeting at a common point. The common point O is known as the origin of the graph, while the perpendicular lines are known as axis of the graph. Look at this picture, we have axis of the graph. Students, look at this table. We have time taken, distance traveled. And again we have a table, time taken, distance traveled. As shown in the figure, the horizontal line x-axis is commonly known as x-axis and the vertical line y or y dash is known as the y-axis of the graph. The value of two interrelated quantities are represented one of the two axes respectively. As an appropriate scale is chosen to represent the values of two given quantities. The values of two given quantities presented in a tabular form are known as data. The graph obtained for this example is a straight line. If you study the Bohr table of observation, you will find that the distance covered by the motorcyclist in equal 15 meters in every second. This also indicates that motorcyclist did not change its speed during his journey. Such a motion is called uniform motion. If an object covers equal distances in equal interval of time, the object is said to be in uniform motion. The distance time graph for body moving with uniform motion is a sloping straight line. Look at this first picture, students. We have graph showing the data given in the table, and come to the next graph showing the data given in the table. So students, these are two graphs. The first is distance time graph of uniform motion and the second is distance time graph of non-uniform motion. The distance time graph for an object with non-uniform motion is a curved line. For a body with zero speed, the distance time graph is shown as a horizontal line parallel to the time axis. Look at here, students. We have this is graph for zero speed object. Now what we learn in this chapter, we are going to discuss it in a nutshell. The events which occur regularly at equal intervals of time are called periodic and give an idea of time involvement. Time is a fundamental physical quantity. The SI unit of time is second. Stop clocks and stopwatches are frequently used to measure short time intervals very accurately. The objects which seem to change their position time to time are said to be in motion. The speed of a moving object is the rate at which distance is covered and is always measured in terms of units of distance divided by a unit of time. The SI unit of speed is meter per second. The average speed of a moving object is the total distance covered by the total time taken at the end of the travel. That means average speed is equal to total distance covered by the total time taken. An object is said to be moving with a uniform speed if it moves along a straight line and covers equal distances in equal intervals of time. A bow is said to be moving with a non-uniform speed if it moves along a straight line but covers unequal distances in equal intervals of time. The physical quantity which measures how far an object moves during a fixed period of time is called speed. Now here we have some keywords. Motion. Change position of an object with respect to time. Then we have rectilinear motion. Motion in a straight line. Speed. The distance traveled by a body in a given time. Speedometer. A device used for measuring the speed of a vehicle. Odometer. A device used for measuring the distance traveled by a vehicle. Average speed. The total distance covered by an object divided by total time taken. Then we have uniform motion. An object is said to be uniform motion if its speed remains constant during motion. Then non-uniform motion. If an object moving in a straight path changes its speed, it has non-uniform motion. Thank you, students. I hope you enjoyed this session. We will meet again in the next chapter. Till then, revise what we learned today.